Hello everyone. Welcome to the masterclass today on flow-based project scheduling, how you can deliver projects on time, even in an imperfect world. Welcome to this session, and please go ahead and introduce yourself as you're joining us here in today's masterclass. And about today's topic, it's about flow-based project scheduling. You may be wondering, what on earth is this technique? Is it the same as the traditional project scheduling methods that we all know about? What's that? What is flow-based project scheduling? I want you to share your feedback or your thoughts on this technique, even if you don't know anything about it. Just guess and type in the chat and let us know what you think this scheduling approach is, flow-based project scheduling. Please go ahead and type in the chat box so we get a feeling of how much you might know about this technique. And are you also aware of the benefits that you will gain by applying this method in your projects? So are you aware of that as well? So let me see if we get some answers from you guys. So we have Sheikh from United Arab Emirates. Welcome here. We have Saeed from Pakistan, Jose from Bogota, Sia, oh, good to see you, Sia, from South Africa, Laura from United States. So great introductions. Thank you, everyone. So Vinat from India, Cesar from Jeddah, Ebi from Toronto. Good to see you, Ebi. So very good. So thanks for the introduction, but also tell us what you think about flow-based project scheduling. So I see a comment by Ayan that he's saying, I know about the importance of flow, except there is a lot to learn about. How? Definitely. So Joshua is saying, is this scheduling methodology similar to monetology by Maury Wool? We will figure that out. Okay, great. So, okay. I don't see that much comments about this flow-based scheduling and whether or not you're aware of that. So, but again, go ahead and share your opinion. So we see how much you know from it. So, and welcome everyone on board. So if you don't know the answer to these questions that I ask, whether or not you know about the flow-based scheduling and the benefits of doing that, no worries at all. That's why we have this 90-minute masterclass with you guys. I have invited a guest who is an expert on the topic and who has implemented this technique on hundreds of projects successfully and achieved tremendous success in doing that on the on-time delivery and enhancing the delivery of the project. So you are here for a good treat and you're going to learn a ton from today's session. So please stay tuned for that. And okay, I just see something popping up. Sorry, I just wanted to make sure everything is okay. So before introducing my guest, as if you haven't done so already, please go ahead and introduce yourself in the chat box. Let us know who you are, from which country you are tuning in from, and also tell us why you enrolled in today's masterclass. What do you want to learn from today's session? Let me just say some highs. Hello, Nish from New Guinea, Zaful from Saudi Arabia, Manuel from Spain. Thank you. So Malin is saying that I think flow-based scheduling is an antidote to P6-based scheduling. So good question. So good guesses, by the way. We will figure those out, everyone. Thank you so much for joining us today. And regarding the goal of this masterclass, we always set the intention right at the beginning of this session, every masterclass we have. So our ultimate goal for you in this masterclass is to show you how flow-based scheduling method can help you keep your projects on track, even if you are experiencing delays, changes, or even have resource limitations. Sounds too good to be true, right? I know. I'm sure you are having a lot of questions and you are curious to know this technique and whether or not it works, because a lot of people talk about on-time completion and this method is the only one, but does it really work? So I want you to bring your questions as we are presenting the topic, and be also open-minded, think outside the box, because the method that we are going to, again, flow-based scheduling that we are going to share with you today is a bit different from the traditional project scheduling method that we all know about and have been practicing that almost on a daily basis. So I want you to be very open-minded, and at the same time, I want you to challenge our presenter so that you are fully aware of this topic, because he has implemented this successfully. So that has been working well, but I'm sure I personally have a lot of questions. I'm sure you will have. So have them coming. We have 90 minutes together, and we will have 2 Q&A sections throughout this masterclass to cover your questions. And the way that we are going to work today, we are going to start off by having my guest speaker starting the presentation by talking about the concept of flow-based project scheduling. So we all know and are clear about the concept. And then we are going to also have a live demo and showing you how it actually has been working on real projects and how it really works. So that's really what we are going to cover today, and that's what our intention is. I hope you're excited about this session and you're here to learn a ton from today's masterclass, and hopefully some of you can apply this in your projects and see the benefits of doing that. Now, if that sounds good to you, I want you to follow also some housekeeping rules as usual. So please have your notes ready so you can have your questions jot down or have the notes for future reference. Also, remove any distractions. If you are here, I know you are sparing time from your busy schedule, and we see people from all over the globe are joining us. Some of you, it's your night time, some is your during the workday. But thank you, first of all, that sparing time from your busy schedule or your family time to be here with us, to be learning something. A big shout out to all of you who are really open to learning. And every time we have a masterclass, you always impress us with your engagement and your enthusiasm for learning. So thank you. So if you're here with us, be fully present and remove all the distractions and multitasking so that you can gain the most out of today's session. And if you've been following us for a while, you know you get rewarded for your engagement in the class. So we always give you as a bonus at the end a copy of the whole slide deck and every resources that we share throughout the master class, so that you have it for your future reference. Also, you can claim 1.5 PDUs, professional development units. And again, the instruction will be provided to you in the handout that we are going to give you at the end. Also, we are going to give you a handout or report showing the result of the flow-based project scheduling in actual projects around the globe and how it works. So you also get that report at the end. But again, that's only for those who are going to stay until the end. Or if you're watching this on a recording later, you need to go through the whole session to be able to download that link for your future reference. Now, okay, without any further ado, let me go and start the session. If you are joining us for the first time, I'm not sure if you know me or not. Of course, let me introduce myself. I am Shore Gorbani, the founder and technical director of Project Control Academy, which is the leading global provider of online training programs in project controls. But I have a very special guest that every time I have him on board, we have a session with him, he makes me think and rethink my assumptions. So I'm very excited for having this special guest today. For today's presenter, he is a Lifetime Achievement Award winner by the Theory of Constraint International Certification Organization for his contribution to project planning and control. He is also the CEO of Realization Technologies, which is also another award-winning company that leverages the smart project delivery system in the project, especially in project planning and scheduling. And under his leadership, the company has helped more than 400 companies on our organization to deliver projects faster and even on time. So please help me give a warm welcome to Mr. Sanjeev Gupta to start this presentation.
Thank you, Shore. It's a pleasure to be here and you always assemble a great audience who ask great questions. So I hope that will be the case today also. And as you said, it's important for people to challenge what I will present, uh, because I think that enhances both my learning as well as the learning for the audience, for the participants. And before we get started, one thing I would like to do is pay tribute to Dr. Ellie Goldratt, who is the founder of the theory of constraints. And he, today is his birthday. If he were alive, he would have been 75 years old today. And in some sense, what I will be presenting today is a culmination of the work that he did what he called critical chain project management. So we will get started. Can I do a quick check? Can you see my slides on the screen? I just want to make
Yes,
sure.
everything is set, Sanjeev. You can get
Perfect.
started. Thank you.
Okay, so let's go ahead. Right, so we know in projects, so I will not go through the statistics of late projects. Everyone knows that projects are generally late. And if we look at what has happened in project management, it is you started with critical path planning sometime in the 60s. The earned value management came along, and a lot of it was all around planned work, which is work that we can foresee and plan. But we know that in the real world of projects, you have changes and delays, right? So then you had some advancement in the form of real-time monitoring, quantified risk analysis. But even with that, the problem of project delivery has not been solved, because there is one more thing that goes on in projects, which is coordination losses. What do we mean by coordination losses? Which is you have work waiting for resources while resources are working on something else, which is not as important, or you have resources waiting for work because that work they're supposed to be doing, it did not arrive from the predecessor resources to them because the predecessor resources were focused on something else. In fact, in 2017, in the conference of Associated Schools of Construction, the one of the papers said that 25 to 50% of the time in projects is wasted in coordination. Now, why is this important? For two reasons. One is we always believe that we don't have enough time in projects, and we always tend to blame our customers, our suppliers, our own people for changes, delays. But the reality is that changes and delays will happen, and that is something you cannot change. Of course, you can try to control them. You need to have good control so that clients are not going crazy making changes to the project all over the place. But that is not the reason for delay. Only about 10 to 15% of the time, according to the studies by McKinsey or even the Associated Schools of Construction, is lost because of changes and delays. The leverage is over here. So if we can reduce this loss, we can both accommodate these changes and delays and also get projects done faster or on time. Right. So first, I will define what this coordination problem is. This is the agenda for the masterclass. I will define what this problem is, like pinpoint what exactly is the problem, what causes the problem. Then we will go into the flow-based scheduling solution, and we will leave ample time for your questions and feedback after that. Right. So we know this. So I'll not go through all this, but this is what we kind of tend to blame as to why projects take longer. We don't live in a perfect world, right? Where resources are available as needed, there will be no delays, no changes. At the same time, if you look at a lot of project planning, it kind of assumes a perfect world, knowing that in the real world, you will have delays and changes, and you will have limited resources, right? So you have this perfect world, which is assumed by the planning people. That is why a lot of times the plans don't get used in the real world, in the execution side, on the front line. Right? So there's a big disconnect between the perfect world that we assume or tend to assume in projects or project management solutions, while the real project managers deal with the real world. Right? So question I'm going to ask you is, when do you think the coordination losses occur? in this perfect world, when everything is going exactly as planned and all your resources are available when you need them? Or in the real world, you have coordination losses, or maybe in the other two quadrants here, where quadrant 2 is you don't have a resource problem, but you just have delays and changes. And quadrant 3 is you have a resource problem, but you don't have delays and changes. And these are hypothetical worlds, but still think about it for a minute as to when do you have the situation where work is waiting for resources are waiting for work. Right? So let's go through a simple thought experiment here. And it will sound a little bit basic, but please bear with me, because I think it's important to see not only what the solution is, but also where we are going wrong in our project management approaches today. So this is a very, very simple project. The real world projects don't look anything like this, unless you're talking about simple things like tasks here that you do around the house. But in this project, you have 4 blue tasks. The first blue task takes 9 days, B1, and the fourth one takes 6 days to do. And then you have 2 green tasks, G1 and G2, and then a purple task. And this tells you how the project is supposed to be flowing. So in this world, of course, you don't have any coordination losses. You will plan the project. You will execute the project. Your plan is going to be 28 days, which is your critical path. Right? I've highlighted the critical path here, and the actual will be 28 days. So really, you don't have a coordination problem in this world. And all you need to do is create a perfect plan. Right? If you can just make sure that you don't miss out on any activities during planning, your project will be done on time. And this is one is where there has been emphasis too much on trying to create perfect plans, because we assume that if we can just think about everything in the project in detail, maybe those changes and delays will not happen. Maybe we will have enough resources because we can forecast how many resources we need, but that does not happen, right? Now let's take it to the second, and this is kind of a myth, which is, let's say that you have delays and changes. By that, what I mean is the first activity, B1, took 3 days extra, B2 took 4 days extra, and so on. Right? So these are the numbers here in terms of how much delay occurred at each step. Do you have any coordination losses in this case? Right. So first of all, the critical path is changed. We understand that. But really, you don't have any coordination loss. You just had a delay, right? What can you do about it? Your resources are available when you need them. So you really do not have to still coordinate anything. Yeah, B1 gets delayed by 3 days, B2 gets delayed by 4 days, but the green resource will be available when the work arrives. So you don't have to worry about coordination. But I think we spend too much time worrying about the delays and changes, whereas the real problem is in the coordination. The only thing you can do here is put some real-time information system that can tell you exactly when the delay is happening, so that you can make sure the delay does not get longer, that you can follow up on whoever is causing the delay. Maybe you can go and do some expediting, but that's all about you can do, right? There's not much more you can do to deliver the project on time. Now, let's take the scenario, make it complicated. Right? In this scenario, you have 4 blue tasks to do, but you have only 2 blue resources available, meaning instead of doing 4 activities in parallel, only 2 of those activities can be done in parallel. Similarly, instead of 2 green resources, you have only 1 green resource, which means you can do only 1 green activity at a time. So now let's see what happens in terms of coordination losses, right? And before we get kind of a little bit dismissive of this problem, let me share with you how would we plan this project if we followed the critical path method, for example. Right? So critical path method would say, let's look at the longest path, which is our 6 days, 11 days plus 7 days plus 10 days. Allocate our first blue resource here. Then let's find the second longest path, which is going to be 10 days plus 8 days plus 9 days. Put our resource here, and after they are done there, then we'll find the next critical path and the next critical path, right? So this is what the critical path logic would say, that the first blue resource would first work on activity B3 for 11 days. Then they will work on activity B2 for 4 days. Meanwhile, the second blue resource will work on the second most critical path, which is B1, and they will move to B4 because that's the third most critical path. And similarly, green 1 and green 2 will prioritize their work, and your project will get done in 41 days. Right? So this is what the critical path logic would tell you. And where I'm going with this is that this is actually an interesting, tough problem to solve. Critical path doesn't give us the right answer, but in the real world, it's a complicated problem. Let me put it this way. You have, just in this simple project, you have 24 possibilities. If you look at a 100-line project, which is, a simple road construction project would be like 100 or 200 tasks, or a complicated project like construction of a refinery or development of a mine or building of a power plant, you will have 100,000 tasks. So you end up with literally millions of combinations, right? There is no way in the world you can scan all those combinations. Furthermore, in operations research is called something like an NP complete, NP hard problem. What that means is that even if I come to you with a solution, there's no way for you to verify whether this is the best solution or not. Right? So just giving you the background as to that this resource allocation problem is actually a tough problem to solve. Now let's look at these options. Right? So 41 days is what came up with the critical path. Here are 6 other options of the 24 possibilities. So you can see there is a wide variation here. You can do the project in 32 days if you allocate resources in this way. It can take 42 days if you do it in this way. This is what we mean by coordination loss. Right? The difference between 32 days and 42 days, or the difference between 32 days and 38 days, is your coordination loss, which is resources are waiting unnecessarily for work to be done to come to them, or work is unnecessarily waiting for resources you could have done better by allocating resources in a different way. Right? So this is the background. Again, this is still an unreal world, because what we are saying here is there's no delays and changes. And the reason it is important to understand that this is an unreal world, because there was a movement in projects also, for optimization. And in fact, there are solutions which kind of come up with different heuristics for different types of projects for optimizing resource allocation. I think where all of them go wrong is that this optimization in detail is a mirage, because real project managers know that we don't know all this work in advance. Over here, it looks great. I know my tasks. I can do this optimization. In the real world, I don't even know how many blue circles will be there. I don't know how long these blue circles will take. Changes will happen, right? I assume that I'll have 2 blue resources. In the real world, when the time comes to execute the project, I don't know how many resources will be available. So, and what you can see is the moment I change any of these numbers, the best option changes. So if I'm constantly changing my plan, my resource allocation, and still not knowing whether the project will be done on time, it's a pretty useless solution. Right? So the cycle you get into with that optimization frame of mind is you say, hey, we need to do the optimization. So let's make sure, so it kind of builds upon the perfect world assumption. Let's make sure that we understand everything about our projects. The reality is you cannot. And then you go into optimizing in detail. So you turn into this cycle of getting more and more data, more and more detailed plans. And the moment you get those detailed plans in place, you start execution. And suddenly what you find is you are spending more time managing the plan than managing the project. Right? So that is why this optimization in detail is a mirage, a trap. So we have to look for a better solution. Right? And let's see what happens when the delays and resource limitations are combined, which is our real world scenario of quadrant 4. So in this case, where are the coordination losses? All over the place, right? And these are the results after the fact. So when we do a post facto analysis of the project, this is what the answer comes out to, right? Again, I want to emphasize the word post facto in the sense that looking forward, I cannot predict how much the delay would be. This is only after the fact that I am finding out what would have been the best result. And a lot of people, again, go wrong here because they assume that, for example, we can run Monte Carlo simulations. And through Monte Carlo simulations, we can see how much the delay would be. But the assumption then they have to make is how much the delay would be. What is the probability of a delay on a task, etc., etc. Right? So, and that is also pretty useless. So now you have complicated your planning problem even further because now you need even more data. Right? So we need to find a solution that is robust, that is for the real world. How do we find that solution? It's a fresh approach that is required, right? So, because if I look at quadrant 1, which is the perfect world scenario, I need to do a detailed planning. If I look at the world where resources are available, all I need is real-time information. And as soon as a delay happens, I need to go and make sure that delay is contained, right? Or you will have this world of super optimization. But let me ask you, think about this for a minute. In quadrant 4, which is our real world scenario, is detailed planning just useless or counterproductive? Right? So again, I'm going to ask, is creating a plan just a useless activity, or is it counterproductive in the real world? In the sense that, would you just spend too much time creating a plan and churning data and not providing useful information to people on the field if you engage in this detailed planning? Similarly, in the real world, reacting to every delay, is that a good thing or a bad thing? So to make you think about that, imagine that as soon as the delays happen, we start changing our resource allocation. Right? So we find a delay, hey, let's change our resource allocation because our critical path has changed. So if you keep doing that, what will happen? Your project will get more and more into trouble because now you are just making resources jump around. Right? So even this real-time information system, which is such a big thing in projects today, and trying to react to every delay is actually counterproductive in the real world. And optimizing in detail, of course, is counterproductive because it's useless. It will never get done because you will never have the data, and you will just create a white elephant of either an information system or a project management office staff. If you try to follow the best practices under the unreal world scenario into the real world, we need a fresh approach. We need to come at it from a different angle, which is that we know that there will be delays. We know there will be changes. We just don't know where the delays will be. We don't know where the changes will be. Right? And I'll define this coordination problem, which is in this real world, which is the uncertain world of projects, How do you allocate your limited resources? Because you have projects is one dimension, resources is another dimension. How do you allocate these resources that are supporting either multiple tasks within a project or multiple streams within a project, or even multiple projects in case of multi-project environments? And also you have these indirect resources. So the managers, the experts, the coordinators, they are not specific to a task. They are what you call level of effort resources, right? They also need to have priorities as to where they should focus their attention. So how do you allocate these limited resources and prioritize work in the uncertain world of projects so as to, because I think this is important, it's not for any other purpose, but the only purpose objective that I'm going to set for projects is minimize the coordination losses, which is minimize the instances or the time lost because work is waiting for resources or resources are waiting for work. So the objective is not to keep every resource super busy. That is not the objective. The objective is that we should minimize the coordination losses. And the reason that is a good objective is that we know from experience that the faster the projects get done, the faster we are able to relieve capacity to take on the next project. The faster the project gets done, the better our cash flow on the project is. The faster our project gets done, the less it costs in terms of at least the overhead costs and also the firefighting costs and also the material shrinkage cost that you experience on site when projects take forever, right? So you optimize your cash flow, you optimize your costs, you optimize your revenues if you get projects done faster. So the only objective is to minimize these coordination losses. How do we do that in this uncertain world of projects? Right. So with this, I will go into the flow-based scheduling solution. And if by any chance, for the moderators, if there is any specific question that has come up so far, before I get into the solution side, I would be happy to address that question now, or we can just wait until the end.
There are some questions, if you don't mind, very quickly.
Sure.
I would like to address them, Sanjeev. Again, it's a comment or question by Kevin, and thank you so much, Kevin, for your asking a lot of great questions before the masterclass and now. So should we clarify the different types of delays? Some are probably just noise. People don't know when and what to react to mitigate the delays. So what are your insights in regards to type of delays that you categorize everything in one category, or it just
That's a
all
great
the
question.
coordination?
That is a great question. So, I will not go into the Donald Rumsfeld analogy of unknowns, knowns, and known unknowns, right? I'll classify the delays differently. So projects, what you have is death by 1,000 cuts, which is day-to-day delays. Some task got delayed. This resource did not show up on time. This material did not show up on time. So there are these kinds of delays, which are really the nightmare scenario for people on the execution side. But there are also some fatal blows that the projects can end up with, which is you have just some unknown risks. So for example, one of our customers, they were building a shipyard and they had these steel supplies, steel plates that was supposed to come from Korea. And this shipping company went bankrupt while the steel plates were on the ship, which means the steel was stuck on the ocean for about 9 months, right? So that is what I would call classify as real risks in the project. So I would differentiate in terms of day-to-day delays versus risk to the project, right? So for risks, you need to, of course, have risk mitigation solutions in place. You need to think about the major risks to the project and create your risk mitigation plans, right? For day-to-day delays, what can you do? They will happen. Now you need to find a solution. Even for the risk, when you create a risk mitigation plan, in executing that plan, you will have day-to-day delays, right? So to round it out, I will just classify these delays and changes into two categories: risks versus day-to-day delays and changes.
Fantastic. And talking about the risk, we have exactly a question on that topic. Ian is asking, going faster, what are the signs that we are trying to go too fast? For example, pushing into the actual work, cutting corners, or increasing the risks to increase the speed. How do we avoid that to make sure that we are not pushing the team or really adding more risks to the project?
Okay, so I will respond it in this way, that I think project managers who work on the front line, they know this. So I don't think I can bring any additional insight into it. People who work on projects, they know the technicalities of the projects, and they know what the end output is supposed to be. So they know what good work looks like, and they know when they are cutting corners. I think the real problem to solve is not defining what is cutting corners and what is not. The real problem to solve is to get these people out of the situation where they have to firefight and cut corners. That is the problem we have to solve.
Okay, great. So a quick question by Deepak. So should we really plan in an ideal way? Why most planners, schedulers do that, knowing the realities? Because when you were talking about those quadrants, and are these done to please the management and clients? I know you're just addressing the pains here, but any thoughts on that?
Yeah, so I did not get the second part of the question. If you can just repeat it, and I got the first part.
So should we really plan in an ideal way? Because as you mentioned earlier, we usually plan in an ideal way and not really considering the limitations that we have. Our plans are really aggressive. So the question is why most of us are doing that, and are these done to please the management and clients?
Yeah. So I think I don't know the answer as to why we do it, but I have been in the world of projects for 25 years or so. So I have a couple of observations. I think one reason we do it is because of just the way things are done. So if you have systems established where you have to, for example, estimate your time and cost in infinitesimal detail, you are going to do it. That is because that is the company process. I think the other big reason, the underlying reason, could be something like this. And bear with me, is kind of stay with me. So if we ask people why projects are late, they say, hey, projects are late because of these delays and changes, right? So what people say is, you know what? Our projects would have been on time if it was a perfect world, right? So this is what goes through our mind. We know that. But then we flip the thinking in a wrong way to say, which means if we want the projects to be on time, we need to create a perfect world, right? So it's saying, if our projects are delayed because the world is not perfect, so if we want our projects to be on time, we have to create a perfect world. And that is just delusionary thinking. So I think, I'm sorry to use such a strong word, but I think it's just a delusion that we all have, that if we can just think and think and think and think and think, we can create a more and more and more perfect plan.
Great. And another question is, so far we talked about the coordination losses. So it's just more about our team and internal coordination. So a good question by Jose. So how to incorporate the external stakeholders into the coordination losses? Great
question. I'm going to answer it after I lay out the solution. And if I forget to answer it, Shorya, just remind me. But I'm going to, I'll make sure I address that.
And perhaps that's another question we have. It's a good segue to the solution that you're going to show. And again, a question by Kevin. So how does this methodology deal with complex projects in some industries, such as internet industry, requiring short delivery with weeks and thousands of projects to be delivered per month, quite different from the traditional project environment? So if you can address that in the solution that you're going to provide, that would be great. So yeah, we can go ahead with the solution, because I'm sure all of us are curious to know how
I will let Kevin be the judge as to the technique that I'm outlining. Does that depend on how long the project is or how many projects you are doing or not? And hopefully what you will see is kind of agnostic to whether your projects are short projects or long projects, or whether you have one project or multiple projects.
And even the industry doesn't matter. Like Kevin is asking, like even IT industry, or is it specific for special industries
Yeah.
like construction or
No, I think
something?
the concept applies everywhere. I mean, we have done implementations, and you will see in the PDF that Project Control Academy will distribute that it is kind of industry agnostic. But right now, my main focus is developing this flow-based scheduling approach for what I would call physical projects, right? The construction projects, the infrastructure projects, because to me that is where the world is spending a lot of money in the coming years, and those are the projects that kind of determine a lot about the growth of a country's economy, especially a country like India. But otherwise, it is agnostic.
And I agree, actually, most of the delays are happening in construction projects. So if you're not good in managing the construction project. So we leave the floor to you, Sanjeev, to continue the discussion and let us know really how it works. I'm sure there would be a lot of questions after you show us the solution.
Okay, so let's go into the solution, right? And one thing I'm going to warn you is what I'm going to present will sound too simple, but I see that as a positive. You might see it as a negative. So let's go there. So the thing I want you to examine is what is the pattern here. So this was our unreal world scenario, quadrant 3. Do you see any pattern here as to which options are the shortest? Why? So obviously in this, out of these 6 options, so there were 24 options. Out of that, I have highlighted only 6. Obviously, option 2 and option 6 are giving me the shortest plan, right? But what is the difference between option 2, option 6 versus other options? So how are these 2 options different from the other 4 options? Just think about it for a couple of minutes. So is there any pattern you can see in how we are allocating resources? Now, let's look at the real world scenario, which is still post factor. With right, again, option 2 and option 4 are, option 2 and option 6 look like the best option in this case. I'm going to just, just with a caveat that there's no guarantee that option 2 and option 6 will be the best options, or the technique I'm going to lay out will be the best options in the real world, because there are so many gazillions of possibilities. But still stay with me, right? What is the pattern that you see in option 2 and option 6 versus the other options? Right? And if this pattern is good, what it means is I don't have to care about predicting where the delays are. Whether I do it in the planning time or in execution time, I am going to end up with more or less the best case scenario if I can identify what that pattern is. And if I can convince myself that that pattern will hold true most of the time. Right? So if you look at it, what you will see is in option 1, I took 2 of my blue resources, put them first, 1 resource here and 1 over here. In this scenario, I put both my blue resources here. And in option 3, I put both of my blue resources here first. And what do you mean by here? Here meaning, instead of splitting my blue resource across 2 integration points, downstream integration points, I said, let me just make sure that I get all the activities for 1 integration point done before I move to the next set of activities. That this is the pattern. And that is what I believe is the golden rule of what I call focus and finish, which is concentrate your resources around as few integration points as possible. If you have limited resources, then look at the integration points in your project and concentrate them around as few integration points as possible. Why does it make sense? Think about it. Your project is nothing but a series of integration points from left to right, right? The project flow mostly gets stuck at these integration points because it's at these integration points you have work waiting for resources and resources waiting for work, both happening at the same time. So if somehow we can get to the integration points faster, our project will get done faster. The second part is, this is very interesting, which is we also minimize the impact, right? Let's see what happens in mode A, which is scattering of resources, versus mode B, which is concentration of resources. When I scatter my resources, my delays start adding up. The delay on the first blue activity and the second blue activity, they both add up because I first work here, the same resource comes and works here. In this scenario, only the worst case delay passes on. So I'm minimizing the impact of this day-to-day delays and changes through this concentration of resource perspective. Let's look at one more advantage, which is if I think about my resource allocation in this way, I have only two options. Either I can do this first or this first. Over here, I have 20 options, right? So I also simplify my planning a lot. Now let's look at one more piece, which is once I start thinking of my project in this way, do I care about how precisely and accurately I know my blue circles, blue dots in advance? Does it matter whether it is 2 dots or 3 dots? Does it matter whether it takes 9 days or 4 days versus 10 days or 5 days? Right? It starts mattering less and less. Right? And not only does it start mattering less and less, but when you do estimates at this level, you are going to have more accurate estimates than you will have estimates at this level. Over here, you will be precisely wrong every time. When you do the estimate at this level, you will be generally accurate most of the time. Right? So there is this is what I mean by the fresh approach. So we are not calling into optimization. We are not going into other heuristics. We are not doing critical path. We are not doing resource leveling in the traditional sense. We are just rethinking the problem from a different angle, from the angle of flow, which is our objective is to keep the project flowing. Integration points are the places where the flow gets stuck the most. The faster we can reach those integration points, the faster the project will get done. Therefore, let's concentrate our resources around integration points. And moment we do that, we also start creating a real world solution which does not rely on very detailed planning, which is immune to changes and delays that will happen as you get into execution.
Sanjeev, sorry for the interruption. Before we move on, we have a question, and that's a valid question on the integration points that you mentioned. Can you have a clear definition of what the integration point is and how we can detect that on the schedule? Because especially if you're working on a complex schedule, there are a lot of links that goes to an activity. So basically every activity would be an integration point. So how do you determine those integration points?
Great questions. That is great, right? So there's a second slide I have, but I'll start answering the question on this slide and then refer to the second slide. And so one set of integration points in the projects are very obvious, right? Where you have installation and commissioning. In the case of, let's say, setting up a power plant or a steel mill. So that is an integration point. A lot of things are coming together. So whenever you are integrating at the system level or at the subsystems level, that is an obvious integration point. Right, and you can think of the project network as just that structure of integration point. But there is what the question might be referring to. There are other links in the project. Let's see what, at least these are the two different categories I have identified, what I call unobvious integration points in project. So one is interactive work. What I mean by that is, let's say that you are doing system design. right? So in system design, you have mechanical and thermal engineers doing their work. But what the mechanical engineer does depends on what the thermal engineer's thinking is, and vice versa. So in some sense, these two activities are constantly sharing information between them. So instead of scheduling them separately, we want to focus those resources on this box together. The same thing happens in outfitting. Outfitting, what we mean by is the building is done or the ship is done, and now you have to lay down the pipes and the electrical wires, etc. And there's a quick handoff between the different trade skills at that point. So that is also interactive work, right? So I think of them as integration points, and I would draw a box around that. And instead of scheduling at this level, I would schedule at the box level. I would think about allocating resources at the box level. The other example, which is not an integration point per se, but it's just a best practice, which is if you are doing a construction project, for example, right? You want your civil work to be done before the equipment installation starts. Or you want your engineering to be all done before the procurement starts. So even though these activities can flow through, but as a best practice, you want to integrate all these three, get it done, and then pass it on to the next set of resources. So this is another example of integration point, right? And for those who are interested, we can conduct a separate session where we can pick up examples from real projects to show you how we draw these boxes so that this question gets answered more than just in an abstract level, and we can answer it in the real world level. Okay. Anything else, Shore?
No, that's about it for now. So okay. Just the clarity from one of our audience. So the interface, integration points, does it mean that interface?
No, integration means that in the purest sense of the word, when you have two different streams of activities coming in and they need to be put together before you can move further. So think of like intersection, right? So you do one part, you produce one drawing, you produce another drawing, both the drawings, when they are done, now we can put it together and put out a bid, for example. So by integration points, really is literally, it is that you have multiple streams of activities coming together and they need to be put together before we can move on.
And we have a comment here by Mohammed that he is saying, seems like sequential plan than a fast track. Is it how it is? Or just can you clarify a bit?
Yeah. So Mohammed, I'll have to take it offline because I don't want to answer the question without understanding what you mean by sequential plan and fast track. So I wish I had more time. I would have done a live discussion, but we can take it offline if you don't mind.
Okay, sure. Thank you. That was all the questions for now.
Okay. Right. So now let's see one other major benefit, which is by when we think of this focus and finish, a lot of other good things follow, which are even better than what I showed you here. Right. So let's see what it means, what I'm saying. So let's say that we have thought about focus and finish, right? And in this, so I'm picking up a slightly more complicated project, but still not as complex as a real world project, where you have three different work streams, or you can think of them as three different projects or three different work streams within a project. For example, you are doing engineering for the boiler, engineering for the coal handling plant, engineering for the water handling plant. And after the engineering, procurement needs to be done, and maybe then something else needs to be done. Or you can think of it during the construction phase, you are doing civil works, installation, and some testing, civil works, installation, some testing, and so on. Right? And the scenario here is that in the first phase, predominantly, I need these blue resources. I need other resources also, but for purposes of simplification, I said, just look at the predominant resource here, which is the blue resource, and the green resource here, and the purple resource here. If I have enough people to do the work, it can get it done in 5 weeks on each of these 3 work streams. So this can get done in 5 weeks. This can get done in 5 weeks. This can get done in 5 weeks. And you can follow the logic, 7 weeks and 4 weeks, which means the project will get done in 16 weeks. But in the real world, I don't have resources for all the 3 work streams at a time. I have ideally resources only for one, right? And the only challenge is that when I put my resources on one work stream, they're not going to be busy all the time. So there's going to be some idle time in between where the resources will just be sitting around. It looks like at the time of planning, just twiddling their thumbs, but let's go with that, right? So if you are a good manager, you know that your resources are limited. You don't have enough resources to do all the work streams, pursue all the work streams. And you also will have delays downstream. So how will you use this limited capacity? In my experience, what people will do is they'll say, let's optimize the schedule. Let's not make sure people don't sit idle. So we can, instead of taking 5 weeks plus 5 weeks plus 5 weeks, which is 15 weeks, we will get the blue work done in 12 weeks total. And similarly, instead of 7 weeks plus 7 weeks plus 7 weeks, we will get all the green work done in 18 weeks. And instead of 4 weeks plus 4 weeks plus 4 weeks, we will get all the purple work done in 10 weeks. Moreover, we will be so smart that we'll keep the work flowing. There'll be an overlap that we will get between the blue and the green. So we can get the project done in 37.5 weeks. This is how people will think, right? Now, this is just planning. So we're just, looking at the planning, meaning we still don't have the situation where delays are happening and changes are happening. But now let's apply the focus and finish principle, which is we'll finish one blue box before we start the next blue box. We will finish the blue box before we start the green box. That is what I mean by focus and finish. So now what happens when we do this focus and finish? Something beautiful starts happening, which is, of course, this is my focus and finish. I finish one blue box, second blue box, third blue box. After the blue box, I finish the green box. Before I start the next green box, I finish this green box and so on. So now you start getting an automatic stagger on the most constrained batches. So if I can do 2 green batches in parallel, then my stagger will be based on the blue box. If I can do 1 green batch in parallel and 1 blue and 1 purple, then I'll get the stagger on the green. So I'll automatically get a stagger for all the work. Think of it like a metering system in the highways. If you have 2 lanes on the road, you cannot put 3 lanes of cars in there. Everything will come to a traffic jam. It's the same thing in projects. The number of lanes you have, you cannot overload those lanes. And you need to also pace the entry of cars into those lanes. If your cars are just don't have much space between them, then again the traffic jam will occur. So what this focus and finish does is automatically starts bringing the stagger into your schedule. The second beautiful thing it does is, see this is buffer. My buffer automatically got exposed. Actually, I got 2 buffers. I got a buffer here in the sense that even if blue activity is delayed, it will not hold up the green activity. Even if the purple activity is delayed, it will not hold up the next purple activity and so on. So I start getting this free buffer. So this is one. The second buffer I got is on the input side. So now in this case, I have to make sure all the inputs are available across all the 3 work streams. Over here, I got a buffer for this inputs. So I can make sure that my inputs are all ready before I start the next work stream. Right? This is huge. We don't have the time to go through the calculation, but what you will find is that your resource requirements also come down. Over here, you need much more resources at any given time. Over here, your peak resource requirements come down a lot. Right? And you can do this. These are advantages. We don't have a lot of time. Otherwise, I would have loved to go into each one of these. The main one I want to focus on is, though, stability of the critical path. Where is the critical path in this scenario? Everywhere. Everything is a critical path. After we lay out the schedule, what you will find is there is not going to be much slack left on any path. There's going to be everything is going to be critical because of resource dependencies, etc. And it's going to keep changing because any small delay here will propagate to a delay here, which will propagate to a delay here. So for example, if my blue resource is stuck on the second work stream, which means they cannot finish that work or move on to the third work stream, this circle on the third work stream. And if the blue resource is unable to work because there's an input delay and I move them to the third work stream, if the delay here was only 2 days, but I move them to the third work stream and it takes 6 days to finish that work, I have suddenly multiplied that delay of 2 days into a 6-day delay. Right? So delays keep multiplying in this scenario. Over here, delays start getting dampened. First of all, the only delays that matter are the ones on the red critical chain. The other delays get absorbed in these buffers. And these delays are not getting amplified. Worst cases, they are getting passed along 1:1. But remember that integration point, focus and finish thing that I showed you. Whatever the integration points are here, so we will not add up those delays, only the worst case delay will pass on in this scenario. Right? So my critical path is more stable. Think about this importance of the stable critical path on predicting when the project will get done.
A couple of quick questions so that everyone is clear. So a question is, by doing this, I mean the approach B that you're sharing, are we adding more work packages to the plan?
Okay, so I don't know the exact context of the question, but if by work package you mean each of these boxes is going to be a work package, maybe not. So sometimes in our situation, this entire thing could be one work package, or sometimes the work package that is given to a contractor could be all the 3 blue tasks. Right? So you are creating these boxes, but these boxes don't represent work package. They are just grouping of tasks. So what you have done is actually simplified the plan from 100,000 line items to about 1,000 line items when you do the planning at the box level. In terms of the work packages, there's no change. You will define your work package the way you define it today. You might define your work package by work stream or by skills.
So you're basically not doing that at the activity level in your schedule, right? So you're grouping the activities together at the work stream to be able to do this focus and finish or flow-based scheduling technique, right?
Yes.
So another question is, so is mode B, or the approach you are proposing, Sanjeev, is it the same as resource-driven scheduling?
It is not. The first one, mode A, is the resource-driven scheduling, where you're trying to optimize resources and making sure resources are busy all over the place. The second approach is flow-driven scheduling.
But again, the second approach still focuses on the resources, right? So based
on that. Absolutely. So it's just that we are coming up with a different approach of resource allocation, which is based on the idea of flow rather than utilization.
Okay. And how about the cost impact? So yes, we are going to have more focused resources on a stream of work, but how would the cost work? By doing this, are we adding more cost to the project?
Okay, so I don't want to dismiss this question because I think it's an important question. So, but think about it. If my project is getting done in less time, and the peak resources are coming down, is my cost likely to go up or likely to come down? And there'll always be kind of, 1 or 2 instances where the general rule will not apply. But in general, the costs will come down because, first of all, your project is getting done faster. Your overhead costs are coming down. Your management costs are coming down. Your coordination costs are coming down, right? And the other way to look at it is, if I am doing in a multi-project environment, then with the same amount of time, I could have done one more work stream, because 7 weeks later, I could have finished one more work stream. So I'm getting more work done with the same resources. So the quick answer is the costs are going to be less here, but I don't want to sound flippant. Again, I think this is worth a more detailed discussion if anyone is interested, and I'll be happy to do that.
Yeah, and we had also some requests on showing that in actual projects for us rather than the conceptual. I think we are going to show you in a minute through a live demo. But before that, just one more clarification before we move on, Sanjeev, on the resources. So are the resources assumed to be the same or all needed to be completing the activity where they are focused? So like those blue resources you are showing, those green ones, are they all the same resources working on that job? Or
very good? No, so that is good. So they are the same type of resources. This is the other advantage, right? So over here I need to worry about skills in detail, right? I need to worry about what is Sanjeev going to do here and what is Shore going to do here, and try to optimize at that level. Over here I say, yeah, Shore is much better than Sanjeev, but is really, Shore, Sanjeev, Saurav, Tom, Joe, they are all resources that do the similar kind of work, and the supervisor will make a decision whether to put Shore on some task because this task is really critical, and let Sanjeev work on something that's not as critical, right? So they're generally the same type of resources, but they might have different levels of skills, for example. This is one. Second is that I could have multiple skills. So imagine the system design activity. So, I could have mechanical engineers and electrical engineers and the thermal engineers all grouped as a crew. So that is the concept of a crew, right? Even in construction, you have a crew of resources that are not all the same. They have different skills. You have a rigger, you have a crane operator, you have a bricklayer, but there's a crew. So these resources are units of crews that we will assign to these boxes of tasks.
Fantastic, Sanjeev. You may move on.
Okay, thank you. Right now, I want to give leave time for questions, so I will fast track through these slides. But think about these questions, right? And that is the advantage of focus and finish. But the last question, this is important. Where did the buffers come from magically in Mode B? Right? How can it be that we suddenly got a buffer in the plan, a free buffer? And how can these buffers be used to manage the resources or for project control? Right? So the quick answer is this buffer is coming from the fact that over here, this buffer is getting lost in all this waiting time. It's not visible. You're firefighting. Because you have collapsed this time here and brought more flow to this, suddenly that exposes this waiting time, unnecessary firefighting time as buffers, right? That is great, because now what that means is that as a project manager, I need to just be worried about how much buffer am I losing. As long as I have enough buffer, I know my blue box is not going to delay my critical path. As long as I have my buffer, I know that whatever prediction I'm getting, I'm going to achieve it. And I can also use these buffers to manage resources, because as I said, we have this blue box, but it does not mean I don't need a blue resource some of the times in this green box. So now I have a priority system to say, hey, if there is enough buffer remaining here versus here, then I will allocate the resources to wherever the less buffer is remaining. It also solves this problem of this level of effort resources. Which problem should a manager solve? Which problem should the expert go and solve? What should we expedite first? Again, the answer is in buffers. Wherever you have more buffer remaining, that assumes a lower priority. Wherever you have less buffer remaining, that gets the highest priority. Now, with that, I'm going to turn it to Saurav. Saurav, are you ready to take on? So you can just take on the screen and I will mute myself.
So, am I audible?
Yes, I can hear you.
Okay. So, so Sanjeev, so I'll just take over from where you started. So what I'll try to do is very quickly show that how this concept of planning in this focus and finish boxes can be translated into practice, because finally we can plan in focus and finish boxes, but finally the work is going to happen in dots, and dots are going to get added during execution. People have to work in the dots, they have to report progress, maybe even below the dots, and that is what people will recognize at the working level. While the box level plan is for the control that you described in terms of the stability of the critical path and the predictability perspective. So I'll start from the place where there is a box level plan, and I'll try to show how that sort of reflects the concepts that you explained. So this is the software for delivering the project in by using the logic that Sanjeev explained. And what we are showing right now, the default starting screen is the portfolio screen, where all the projects are listed down. And what the system is trying to do is it's trying to sort of give uh, the top management an idea as to where their problems really lie. So there are some color codes. The one in red, there's one project in red, some two in orange, there are a few in yellow, and then it goes into green. So what red typically means is that the system, the due date is 31st August 22, and the system is projecting it's going to end up in 27th April 23. And because the gap is so big, the system is trying to tell you that this has gone too far out, and probably it is very difficult to complete within the given due date, and it's turning it red. While the oranges also, you will see there's some amount of delay, but the system is trying to tell you that it's not that big. Maybe there are a few decisions that you can take and you can still get your project back. The ones in yellows are going more or less on time, and so the project management team is able to take care of them. The ones in green are going ahead of time, so you don't need to worry about it if you don't have enough time to review all the projects in your portfolio. Now we'll get into the distillation project. How is the system predicting? Because Sanjeev gave the concept that this way of planning makes it more predictive. But how is it predicting? So we can dive into the next level of detail, which is the level at which Sanjeev explained, the box level of planning. So I'll just quickly try to give you an idea of what that box level plan is saying. So the first thing, this is the live picture of what is happening to the box level plan, which means it might have started in a different way, but based on the progress that has happened so far, we are standing here today, and this is the due date. So based on all the progress we have made in the past, this is the live situation of that box level plan or the box level network. And you can see there are first work stream, second work stream, third work stream, fourth work stream, etc. So how is the system creating these work streams? Is that there are underlying dependencies like Sanjeev showed in the PPT, which are running across the plan. The system is calculating this network and figuring out the work streams by itself. It's like a path. So it's basically finding out all the possible paths that are there in the system. And it's telling us that, okay, if you have to take action, this is the place where your action needs to be, because this is what is determining where your project is going. This is the right now the critical path of your project at the box level. If you take actions anywhere else, it is not going to help. Now, if we look at this path and we also see the second, third, fourth, what these are saying is these are less critical than the first one, but for the second one, you can see there's a buffer, which Sanjeev mentioned, that there are buffers created, and all you need to understand is how much buffer are you losing. It's also telling you that in the second work stream, you have actually lost a lot of buffer, and that's not much different between the first and the second work streams. So you need to be worried about both. Whereas from the third work stream onwards, you can see the size of the buffer is pretty big. So you don't need to worry too much about them. Even if they get delayed a little bit while getting executed, there's enough cushion available to protect them from hurting the end date of your project, which is the diamond. So this is the primary construct. Now the question is, how is the system predicting this? Because this is the box level plan. And as we discussed, that bars are not the level at which people work or people recognize the work. They work at a level of the dots. So where are the dots? So if we look at the first task, which is the design task of civil and structural blocks, there's a plus sign. So you can go inside. And there is a detailed network inside, which is about the model review of a process block, which is just a detail, which is complete right now. Then there are civil drawings and there are the structural drawings. So the civil drawings is almost about to finish, and then the structural drawings still remaining. And civil and structural are connected. Only after completing this can the structural engineers complete their structural drawings. So this is the job of the engineering team. Now, one thing to note is this structural drawings, as soon as we complete the civil drawings, technically we can start the civil works. But as Sanjeev mentioned in that discussion about integration points, about the unobvious integration points which exist there in the plans, which is civil drawings can lead to civil works, structural drawings can lead to structural works. And if I look at the next block, which is the civil and structural works.
Just a question on that sort of, so on the example that you showed, like the whole design was just one box. So it's too high level to plan that at that level, because how do you assign resources to that 8-month project? And you don't have much details built in the schedule. How do you do that effectively on just the example you showed for the engineering? If you elaborate more on that, that would be great.
Sure. So two things. One is, let's first get into the details. So this is going on for a very long time. It can be due to uncertainties, etc., other reasons. Doesn't mean it was planned for that long. But just coming to the point of how do we know the resources and how to assign resources in higher levels of detail. This is not the end. It is connected to the lowest level of detail. You can keep drilling down, which takes you to the level of the drawing names, the steps that each drawing has to travel in order to get completed. So for example, what I say in civil drawings, you don't have one drawing, but in individual details. Each drawing has to go through the initial drawing submission, then the feedback and comments, then the good for construction drawing submission, and then approval. So there are steps in each of them. So each drawing is going to the micro level of detail where you can assign resources if you want. Does that answer one part of your question as to the level of detail it's actually?
Yeah, so we thought it doesn't show the details, so it's just by click you see the details. Thank you. Yes.
Yeah, so it keeps going down. So you start at the box level, you can drill down to the dot level, and you can drill down to the dots of the dot level as well, and you can assign resources there. All it is doing is, after you do all this, it is rolling up and telling you what is your requirement at this level. And so that so there's not only one design box which is available there. If I quickly filter for all the engineering type of tasks, then there are 1, 2, 3, 4, 5 of them, right? All it is saying is, out of the 5 which is required for the entire project, right now, your resources need to be focused here. If there is a shortage, so right now you can see 3 of them are coming in parallel. Let's assume 3 of them require, let's say 30 people, 30 engineers, and we only have 20. So what the system is saying is, then sacrifice this. Make sure these 2 are fully loaded so that the speed of this boxes can be maximized. We still have a lot of feeding buffer to absorb the delay if this starts a little bit late while we are trying to mobilize more engineers to take up the entire scope. Does that answer the question, Shuri?
Yes, thank you so much
It's
for
not just
clarifying,
one.
Saurav. I
Yeah.
appreciate that. Thank you. And one more question on this. So is the uploaded information needs to be done on this software, or let's say if you're using, that's a question by Sheikh, if you're using another software, it can be rolled out to this, what you're showing here.
Yeah, it can be. So the details can come from any other software, right? We have to just make sure that it's mapped according to the boxes. So in this case, it's an automatic thing. The boxes are the starting point. The details always are inside the boxes, so it's already pre-mapped. But if you are trying to pull details from other system, you just have to map them to the right boxes. That's all. But it can do the same thing.
And how do you break the activities into work streams? That's a question by Joshua.
Okay, so we don't break the activities into work streams. We just define the boxes, just like Sanjeev said. We try to understand where the integration points are, because the problem that Sanjeev showed was the problem is arising when there are integration points and there are resource shortages, right? So we are trying to only figure out by looking by understanding where those integration points are, and we are defining the boxes accordingly, right? And we are defining the dependencies between the boxes. The work streams are getting created by the system. We have nothing to do with that. So
And just one more thing before you move on. So if anyone is interested to see that how it works for your own projects, you can see a link on your screen that you can schedule a customized masterclass for your own project to see how it actually works and how you can do that. But hopefully that gives you the concept here. And sorry for the interruption. Saurav, you may go ahead.
Yeah, sure. So coming back to the unobvious integration point. So if I look at I'm sorry, I clicked the wrong box. So if I look at the civil and structural works, you can see that we could have started the civil works right after we get the civil drawings, and then the structural drawings can come in late, right? So this is the unobvious integration point. This structural work requires both the civil work to get done and that structural drawing to come in and meet it here. So this is the unobvious integration point where logic that's a box of this the box can happen without
We
having
lost
to
your
worry about.
voice. It kind of comes interrupted a bit. If you just repeat what you said, we didn't hear you, Saurav.
So go inside the drawings, right? So there are civil drawings and then the structural drawings. And if I go inside the work of the civil and structural contractor, there is civil works and structural works, and then some flooring and equipment foundation works, right? So if we think of the engineer consultant and the contractor, then they can work in the dots and try to work in an overlap fashion, which is the unobvious integration point problem that Sanjeev had shown before. So the way to model the boxes would be to take off engineering in one box, hand it over completely, and a clean handover to the so that the accountability, the handover, everything is very clear. And there are no integration points to manage after the contractor starts the work. And what do I mean by managing an integration point? If the contractor starts the work before all that entire engineering is work, then you can see in structural work, it might have to wait after civil works is done because the structural drawings have still not arrived. So we are avoiding that by completely making it a clean handover. So this is one part. The other part that Sanjeev had described was when we are talking about interactive work, which happens typically in the installation piping, in the installation phase where piping, electrical, instrumentation, everything has to happen together. So here we have a combined network for all those people working together but the way of resource allocation is simply to have a combined team dedicated on this box, so that whatever happens inside the box, there is no shortage of resources. So all we are trying to do is either avoid the integration point or avoid a shortage of resources. That's what we are doing by creating these boxes. That's the logic. So this is one part of what Sanjeev showed, how it works. And here also, you can keep drilling down to whatever level of detail you want. You can have more drill downs inside to go into deeper and more dot level information. Another thing to note is you can see that plus sign exists in some of the boxes, but in the later boxes, the plus signs do not exist. Uh, this is with reference to one of the questions Sanjeev raised, that what happens when dots get added later. So the box level plan is good enough to give you the predictive information that you require. That also means that we do not need to create a very detailed schedule right at the beginning when we don't have all the information. This supports a rolling wave planning, which means as we go ahead, as more and more boxes gets completed, we get more information, we start detailing the subsequent boxes. We don't need to do them all upfront. This is also how the system is calculating this map in a real-time mode. Is it is not taking any promises from anyone. It is going down deep into these details. This is the only place where progress is getting recorded, and from the speed at which the progress is happening, it is figuring out what is the impact on the entire box. Then it's rolling it up. It is recalculating, rolling it up, and predicting by itself based on only the progress data. Nothing, no promises, only the progress data of actually at what pace work is happening. It is figuring out what is the impact on this box, and therefore what is the impact on this entire plan. And that is how it is calculating the impact by itself.
Thank you so much, Saurav. Can we now go? We have a few more minutes left. Can we go through some questions, or if there's anything else left you want to show quickly?
No, not much. It's the only thing I wanted to show was it follows what Sanjeev described about. So I'll just want to quickly take commissioning. So what it is showing is that there are basically three work packages. This is the main work package. This gets commissioned here, and then the entire plant is commissioned. And there are two other work packages which need to get commissioned before for the entire plant commissioning to happen. And you can see that this is one major integration point for the entire plant. All three have to be ready in order for the final plant commissioning to happen. So as you can see, it automatically gets staggered, like Sanjeev mentioned, that there are buffers to protect the final integration point. So that even if delays happen here, this doesn't run away.
So if you don't mind, I have a question for you, from Ayan. So with the example that you showed, with the civil design consisting of many individual drawings, are you delaying the issue of every single civil drawing until the last one is complete? Is there not a risk that are creating waves of work and queues by passing work forward in large batches? And the final part of that question is there a sweet spot between a one-piece flow of design information and very large batches that create delay and risk?
Yeah. Okay, thank you. So don't go by this specific example. So the sweet spot is probably a good point. So we are creating the sweet spot at the time of planning itself. What is the right package to hand over? Okay. So imagine this box. Don't think of it, because it's a specific example, and we have not been able to share too much information of how this project has been conceptualized, etc. So imagine you start with your sweet spot batch, whatever you think is the sweet spot, is the right. Let's say for a civil works, we say that, okay, let us at least hand over the substructure drawings. Superstructure can come later, but at least the substructure drawings should go for the contract
Sorry, Saurav, we lost you completely here. So can I have Sanjeev joining us here and answer the questions? Yeah, we don't hear you, Sanjeev. I think you are muted. And since he is sharing his screen now, things are... Yeah. Sanjeev, do you hear me? I don't hear you, though. Perhaps you are muted. If you can unmute yourself so we can go through the questions. We don't have much time left. Sorry, everyone. It seems that we are facing some technical difficulties. Not sure what's happening here. If I don't hear Sanjeev, I hope you are hearing me. So, Sanjeev, do you hear me? I don't hear you at all. Here you go. I don't hear you. You are muted, or? Okay, interesting. So I don't hear Sanjeev. Does everyone hear Sanjeev, or it's just me? Okay, it seems that we lost the connection at the end. So do you hear me? But you don't hear Sanjeev, right? Yeah, we don't hear you, Sanjeev. It seems that we lost you. So
am I audible?
yeah. Okay, so we don't hear Sanjeev, so it seems that we won't be able to go through the questions unless, Saurav, you want to jump in and answer some questions because we lost Sanjeev's voice here. So just a lot of questions came on the application you were using, Saurav. What application was it? What software is it? And can you integrate that with other scheduling tools as well?
Yeah, the short answer is yes. This is our own patented software. And yes, it can be integrated with other softwares. But as I said, the driving part is this box level plan, and everything has to be mapped to it.
Okay, fantastic. And
Sorry,
just
quickly trying to give an answer to that question about the size of the batch, etc. What is the sweet spot? If I'm audible, I just want to quickly give the answer to it.
Yeah, please go ahead. We have just a few more minutes left. Yeah.
So the sweet spot is a decision that you take before when you're creating the plan. So don't go by this example. You can have your sweet spot. Just to take a quick example, if for civil works we say that okay, let us at least give the substructure drawings to the civil contractor so that work can happen faster. We're not saying give the drawing for the entire building. So you decide your sweet spot. But once you have decided the sweet spot and defined the box, all the system is trying to tell you is whether it is being met or not being met. And you have the option of starting a bit early if you are sure that this box is going to get completed quickly. So it's a call that you will take. It's the system is only giving you the visibility of what you thought the sweet spot is, or the right way to do the work should be.
And if you can activate your camera so we can see you, that would be great. I also had some audience who raised their hand. If you want to join us in the live room and ask your question, you are more than welcome. Just raise your hand. We have we are allowing 5 more minutes for Q&A. But if you have more questions that we don't have time to cover, Artem already put the email that you can contact Sanjeev directly and ask your questions regarding to that. Also, you can schedule a customized masterclass with your own project so you see how it actually works in action, because I know it's a new methodology. I mean, not all of us know how it works. Sanjeev, I see you're back. Just can we test quickly whether or not we hear you again? No, we completely lost you.
That's okay. I can take the questions if it's
okay. So now regarding some questions here, and if you can activate your camera so we don't see you there. Some questions here. What is the, okay, we talk about the scheduling software. So does the work boxes fit into the applied timeline? Boxes are splitting over the timeline. So if you just elaborate more on the boxes that you showed.
Okay, so boxes are, I didn't get the question exactly. What do you mean by fitting into the timeline?
I don't know. Does the question is by Joseph? Does the work boxes fit into the applied timeline? Boxes are splitting over the timeline.
So the boxes, I mean, the plan that you create has to meet the timeline that is the target due date. I mean, we cannot create a plan that actually overshoots the target. In fact, what Sanjeev had showed, that when you create the boxable plan, it actually takes shorter. So it should always meet the timeline.
And another question by Ishan, does flow-based management compare to a Scrum management method? And what are the pros and cons on both in construction projects?
Not exactly. I don't think they are okay. They have similarities, but it is not exactly the same same concept. So the flow
We lost you again, Saurav. Sorry, we lost you again. So yeah, it seems that at the end we have some internet connection issues. Sorry, everyone. I apologize for the technical difficulties we are facing now at the end. So if you have any question on the topic, our team already put the email that you can contact the team directly and ask your questions. So I will also make sure to forward your questions to Sanjeev so he can also provide an answer if we didn't have the chance to do so. Again, apologies for the technical difficulties at the end. I hope this masterclass gave you a new approach to project scheduling, which is more focused on the flow of the resources and how we can do things faster, even with the limitation of the resources or the delays that we are experiencing. I know there are a lot of questions on how we can actually do that on our projects, and that's a valid question. Still, that's my question too. So again, they were kind enough to offer 3 sessions, kind of customized session with your own projects that you can see how you can do that in action, and the links already provided on your screen. So make sure that you book that. There are only 3 sessions available. So if you want to take that opportunity, by all means do that. But they have actually implemented the flow-based management in hundreds of projects and got tremendous results on time completion. But how it actually works and really in our projects, I'm sure, yeah, we can, again, that's, we are already passing the time and we cannot go over to all of your questions. So apologies, but hopefully on the manual that we are providing you with our contact information, there are also case studies that you can go over. And again, if you need more information, we have already provided the email on the chat that you can contact the team directly. So thanks again. Sorry, I have to adjourn the session due to the technical difficulties that we have and couldn't go over the questions. So Sanjeev, if you're hearing me, I'm going to send all the questions to you. So if you can assist those whom we couldn't answer, that would be fantastic. And thanks everyone for joining us today. I hope that added a lot of value and hope that helped you, give you a kind of new perspective on project scheduling and how we can do things differently. Thanks everyone. See you in the next masterclass. Bye for now.
Bye.